Are you evaluating a code quality and security platform and wondering whether SonarQube is the right choice for your team, and if it uses AI? In this in-depth review, we will explain exactly how SonarQube works, what it does best, where AI fits in, how it integrates with your CI/CD, how it is licensed, and what to watch out for during implementation. At its core, SonarQube is a comprehensive self-hosted platform for continuously inspecting source code. It performs static code analysis, meaning it examines code without executing it, to uncover bugs that can cause incorrect behavior, vulnerabilities that could be exploited, and code smells that increase long-term maintenance costs. Unlike simple linters, SonarQube brings together curated rules for over 25 languages, centralized governance, pull request decoration, and historical reporting so you can enforce standards consistently across teams and repos. SonarQube is published by SonarSource, the company behind SonarCloud, its hosted SaaS sibling, and SonarLint, the IDE extension that brings rules and issue explanations directly into editors like JetBrains IDEs, Visual Studio, and VS Code. Organizations often combine these tools to achieve a clean, consistent developer workflow. Find issues early in the IDE, verify and pull requests with SonarQube, and track portfolio health in dashboards. The platform's architecture is straightforward. A SonarQube server provides a web interface for browsing issues, trends, and metrics. A relational database stores configuration and historical analysis data, with PostgreSQL commonly used in production. Scanners run during your builds to analyze code and push results to the server. You can run Sonar Scanner via CLI or use build tool integrations such as Maven, Gradle, and MS Build. CI orchestrators like Jenkins, GitHub Actions, GitLab CI, Azure Pipelines, and Bitbucket Pipelines are all first-class citizens. In practice, you add a short step in your build pipeline that authenticates to the SonarQube server, analyzes the codebase, and publishes the results. SonarQube groups findings into 3 types. Bugs are likely to cause failures or incorrect behavior. Vulnerabilities expose security risks and are mapped to standards such as OWASP Top 10 and CWE. Code smells or maintainability concerns such as large classes, complex functions, or duplicated code that drive up technical debt. Additionally, security hotspots highlight code that requires human review, such as cryptographic settings or use of APIs that can be safe or unsafe, depending on context. A key value proposition is the quality gate, a policy that determines whether a project or pull request meets your organization's standards. Most teams adopt a clean-as-you-code approach. They do not attempt to fix every legacy issue immediately, but they block the introduction of new problems on changed code. Quality gates typically include conditions on issue severity, test coverage on new code, and duplication thresholds. This approach steadily improves code health without stalling delivery. On the security side, commercial editions of SonarQube add advanced static analysis with taint tracking to follow user-controlled data through the code and detect injection vulnerabilities like SQL injection, command injection, or path traversal. These rules are aligned with common frameworks and languages, and they are updated by SonarSource as new patterns emerge. While SonarQube excels at static analysis, it does not replace software composition analysis or dependency scanners. Many teams complement it with SNCC, Dependabot, or similar tools, and with secret scanning to catch credential leaks. Where does AI fit in? SonarQube's core engine is rule-based and deterministic. This provides transparent, consistent, and explainable results, which is crucial for maintainability and auditability. In recent releases, SonarSource has introduced optional AI-assisted remediation features aimed at helping developers understand issues faster and propose candidate fixes. These AI helpers do not replace the rule engine. They augment the developer experience by accelerating remediation while leaving final control with the engineering team. SonarQube supports a broad set of languages, including Java, C#, C and C++, JavaScript, TypeScript, Python, Go, PHP, Ruby, Kotlin, Swift, and more. Each language has tailored rules that reflect idioms, framework usage, and common pitfalls. Metrics include reliability and security ratings, maintainability ratings based on estimated remediation time, coverage percentages from your test reports, and code duplication rates. For coverage, SonarQube ingests reports produced during builds such as Jacoco, LCOV, Cobertura, or Visual Studio coverage data. Pull request decoration is one of the features developers love most. SonarQube posts inline comments and a summarized status to GitHub, GitLab, Azure repos, or Bitbucket, so reviewers see exactly what changed and whether the code meets the quality gate. This creates an efficient feedback loop. Developers address issues while the context is fresh, rather than letting problems accumulate. On licensing and editions, Community Edition is free and suitable for many open source or smaller teams. Developer Edition adds branch analysis, pull request decoration, and advanced security rules. Enterprise Edition layers on portfolio management, governance, and more scale-oriented features. Data Center Edition targets high availability with clustering and enterprise-grade resilience. Commercial licensing is based on the number of analyzed lines of code across all projects. Implementation is usually straightforward. Plan for right-sizing the server and database, especially for large monorepos. Cache dependencies and CI to keep scanner runs fast. Start with a sensible quality gate focused on new code. Curate quality profiles per language. Disable overly noisy rules. Enable rules that reflect your standards, and document exceptions. Establish triage routines so that security hotspots and critical issues are reviewed quickly. Finally, roll out SonarLint across IDEs and connect it to SonarQube so developers see the same rules locally before they push code. Common questions include performance impact, accuracy, and coverage. With incremental analysis and caching, the build overhead is typically modest. False positives can occur, but SonarSource continually improves rules, and you can mark issues as acceptable with clear workflow controls. For coverage, ensure your test stage runs before the analysis step, and that reports are correctly passed to SonarQube. This guarantees accurate quality gate decisions on new code. How does SonarQube compare? Against enterprise SAST products like Fortify, Checkmarks, and Veracode, SonarQube often wins on developer adoption, tight PR integration, and total cost of ownership, while some specialized SAST platforms go deeper on certain vulnerability classes. Against GitHub CodeQL or SumGrep, SonarQube emphasizes turnkey rules, governance, and clean-as-you-code workflows, rather than highly customizable querying. For teams on cloud-first stacks, SonarCloud removes the need to run the server yourself while providing a similar developer experience. If your goals are to reduce technical debt, prevent new vulnerabilities at merge time, and build a culture of clean code, SonarQube is a strong and proven platform. Its rule-based engine provides consistent findings, optional AI assistance can speed remediation, and its integrations make it a natural fit for modern DevSecOps pipelines. With careful tuning of quality profiles, pragmatic quality gates, and developer-first adoption via IDE plugins and PR decoration, you can raise code quality across your organization without slowing delivery. In short, SonarQube remains a leading choice for teams that want measurable improvements in reliability, security, and maintainability, driven by clear policies, actionable findings, and seamless CI/CD integration.